Welcome friends in the lecture series on thermodynamics. This is lecture 6. In this lecture we are going to understand macroscopic and microscopic approaches in thermodynamics. This topic will also act as foundation for the topic concept of continuum. So let's start this topic. We all know each substance is made with large number of small particles, and these particles are known as molecules. Consider a system having some substance which can be a solid, liquid or maybe gas, and these are the molecules of that substance. The actual value of molecules will be very high, and this is only the representation of the molecule in the substance. If we consider a small portion of the system and view this portion with the help of microscope, we can see the actual arrangement of molecules in this substance. If this substance is solid, then the arrangement of the molecules will be like this. If this substance is liquid, then the arrangement of molecule like this. And if it is gas, then the molecules are in this pattern. So we can see in the solid, the molecules are closely spaced and the intermolecular distance, which is the distance between the two molecules, is very low. This intermolecular distance in case of liquid is higher than the solid, and in case of gas it is highest. So the intermolecular distance is highest for gas than liquid and the least for the solid. It can also be observed from the figure. In a taken portion, if the substance is solid, the number of molecules are very high, and if it is liquid, the number of molecules will be less than the solid, and if it is gas, the number of molecules will be least. So the number of molecules will be less for the liquid and gas in comparison to solid. Still, if we calculate, we will find if this liquid is water and this gas is oxygen, then at normal pressure temperature condition, in a tiny volume of 1 mm³, which is equal to a droplet of water, the number of molecule will be very high. So if it is water, then in 1 mm³, the number of molecules approximately 3 into 10 to the power 19, and if it is oxygen, then the number of molecule will be 3 into 10 to the power 16. The number of molecules in the gas is 1000 times less than the liquid. However, the number of molecules in the gas is still very high. The properties of the substance naturally depend upon the behavior of these particles, because the substance is made with the molecules. So its property depend upon the behavior of these particles or molecules. Let's take any property, let's say density. Generally, the density of solid is higher than the liquid and the density of liquid is higher than the gas. Because solid has higher number of molecule, liquid has less number of molecule, and gas has least number of molecules. So we can say properties depend upon the molecules. These molecules also have different type of energies, and due to which in the solid the molecules kept on vibrating in their positions, and in the liquid and gas they are free to move randomly due to the kinetic energy. Suppose in this portion we have a substance which is gas, and these are the molecules of the gas. These molecules have different type of energies, and due to which they do random motions. So if we zoom this volume, we can see the molecules are moving here and there randomly in a zigzag manner and exchanging their energy by colliding with each other and with the system wall. So let's zoom it. We can see molecules moving randomly and exchanging their energy by colliding with each other and system wall. And the property of any system depends upon the behavior of these molecules. So the property of the system depend upon their velocity, change in momentum, etc. So if we talk about any property, let's say pressure, which is the force exerted by this gas on the system. So for this system, the pressure which is equal to the force exerted by these gas molecules on the system wall. If the pressure is low, it means the force exerted by the molecules is low. If the force exerted by these molecules on the system wall is high, it means the gas has high pressure. According to the kinetic theory of gas, temperature of a gas depends upon the level of kinetic energy of the molecule. So if the kinetic energy of a molecule is high, then system has high temperature. Or if the kinetic energy of the molecules is decreased, then the temperature of the system is also decreased. Hence the properties depends upon the molecular behavior. Consider a piston cylinder arrangement in which some gas is filled. At this condition, pressure inside the system is balanced with the atmospheric pressure and weight of this piston. If we transfer some amount of heat to this system, then the temperature of this gas will increase. And according to the kinetic theory of gas, due to which kinetic energy of these gas molecules will be increased, due to which it exerts more forces on the system wall and the pressure inside this cylinder will increase, due to which piston will move upward to establish equilibrium with surrounding. So far we are only creating background to understand macroscopic and microscopic approaches. If we want to analyze any thermodynamic system, we have two approaches. First one is microscopic approach and second one is macroscopic approach. So let's understand microscopic approach first. Consider a container in which some gas is filled and these are the molecules of this gas. We want to determine property pressure for this gas. In microscopic approach, we have to examine each molecule, their velocities, their mass, their kinetic energy and their momentum transfer. So if we have n number of molecules, then we will get n numbers of equation. One equation for one molecule. So total we have n number of equation, and by solving those equations we can determine the pressure. So it is a very complex process because we have to solve the equation for each molecule, and after that we will take the average to define the property. However, in the second approach, which is macroscopic approach, we take a small portion inside this system and we will find out the average behavior of molecules in this volume, and with the help of that we can define the property for entire system. Suppose in this small portion, molecules exerting force on the wall of the system which generate the pressure, which we can measure easily with the help of pressure gauge, and we can tell the value of pressure for the entire system. So in the macroscopic approach, we consider only a small portion in the system and we find out the average behavior of the molecules in this portion and determine the property for entire system. The value of pressure will be same from both approaches, microscopic and macroscopic. However, this microscopic approach is too simple. So let's understand this microscopic and macroscopic approach one by one. So first take the macroscopic approach. In this approach, a certain quantity of matter is considered without taking into account the event occurring at the molecular level. So we are not considering the molecules in this approach, and this approach is also known as classical thermodynamics. This macroscopic approach to the study of thermodynamics does not require a knowledge of the behavior of individual particle. So in this approach we do not require any knowledge of individual particle. It provides a direct and easy way to the solution of engineering problem. So this approach is very easy, and in the 90% cases in the thermodynamic analysis we use macroscopic approach. Now let's understand this microscopic approach. In this approach we consider that system is made with a large number of molecules and we are concerned with the behavior of each molecule. So in the study we will take behavior of each molecule. These molecules have different velocities and energy, and the value of these energies are constantly changing with time. So this type of study is very difficult to do. Since we are doing calculation for each equation, so we have large number of equations and these equations are solved with the help of statistical techniques. So this approach is also known as statistical thermodynamics. So this microscopic approach has a very limited use in the thermodynamics, and it is only used to determine the properties which are associated with the molecular level, like internal energy, entropy. However, the microscopic approach is always used to support the macroscopic approach. As we have already seen in the last example, when the heat is transferred to the system, its pressure is increased. So we can say it by the experience of microscopic approach. So let's discuss the differences between the macroscopic and microscopic. So this approach to thermodynamics is concerned with the gross or overall behavior. And this approach of thermodynamics is concerned with the behavior of each molecule. So it is clear by the nomenclature. So it is a macro, so it means it concerned with the gross behavior or overall behavior. And this is micro. Micro means it is concerned with in the molecular level. The analysis of macroscopic system requires simple mathematical formula, and in the microscopic approach we are dealing with a number of molecules, so we require statistical or large number of mathematical formulas. The microscopic approach is known as classical thermodynamics, and the microscopic approach is also known as statistical thermodynamics. So if we want to describe a system in a macroscopic approach, we require only few properties like pressure, temperature, volume. But in case of microscopic approach, we require large number of property to define the system. Microscopic approach is less time consuming, and the microscopic approach is more time consuming. In the macroscopic approach, the calculation is simple, and in the microscopic approach, the calculation are complex. This macroscopic approach is useful for high density, or when we are dealing a system which is at above the vacuum pressure. This microscopic approach is useful for low density gases or the gases which are at vacuum pressure. So this microscopic approach generally used when we are dealing a system which is in vacuum. Microscopic approach is based on the assumptions of molecular theory, and this macroscopic approach is based on the assumption of concept of continuum. If the concept of continuum is valid for a system, we can apply the macroscopic approach. So it is very important assumption, concept of continuum, and the meaning of concept of continuum we will see in the next lecture. So this is all for this lecture. Thank you.